Hey everybody, it's Mrs. Peachy, your physics teacher at Wisconsin Connections Academy. Today I am going to do a video tutorial on the Projectile Motion Laboratory, which is in Unit 1, Lesson 5. And actually this is your first lab for physics for the school year, so there's lots of stuff we need to go over to make sure that you do a good job. One of the things you're going to notice about physics labs is that most of them, and I think all but just a couple, start off by asking you to design a hypothetical experiment. So you need to know about the concept that the lab is covering prior to actually doing the lab, and that will allow you to draw upon your knowledge to kind of fashion an experiment that you might be able to do in real life instead of just the virtual experiment that we're going to be doing on the computer. So think outside the box a little bit. Think about what could you do to test, in this case, projectile motion in the real world, and how would you test it, and how would you get the data, and that kind of stuff. So first of all, let me take you to the my website. If you look at the bottom of the screen, you guys know to click on the pushpin icon to take you to the message boards. And if you follow the message boards to my website, then you will see my Google site here. And you will also notice that at the top of the screen there is a tab for physics. So you're going to click on that. And in this tab for physics, as you scroll down, one of the things I hope you notice is the lab rubric. So if you clicked on that lab rubric, it would bring up this Google Doc for you. And one of the things that's on here is the introduction/hypothetical. So this is where you would discuss that hypothetical proposal. How would you do this lab in the real world? And this is where you would also give an introduction to the lab that you are actually going to complete in the virtual world. So both of those things need to be covered in this introduction. Then you need to create a hypothesis. Remember, your hypothesis should center around your dependent and independent variables, right? So you need to figure out what is your independent variable, what is the thing that you are changing or manipulating in this experiment, and what is responding to that change. So that's called the dependent variable. It depends on what you've made the independent variable, okay? So if your independent variable, say, is the height of the cannon, the dependent variable may be how far the cannon shoots, or whatever it is you've chosen to make your variables. Also, with the hypothesis, you may be used to doing an if-then statement, but because you are at an upper level science course, you need to make sure that you also give a reasoning for your hypothesis. If I do this to the cannon, then this happens to the range of the projectile motion because, and then you explain the scientific reason why that should occur, and back it with evidence from the text. So go back to your textbook, find information that actually supports your hypothesis, and that should be cited as part of your hypothesis. Okay? So you'll see that to get full points, you have a reasonable hypothesis that is backed with text-based evidence. Next is your data tables. Data tables have to be well organized, labeled, and correctly done. Your graphs, if needed, in this case you will do graphs. Again, the right type of graph conventions are correct, labeled axes with units, trend lined, all those types of things. And calculations. If you do any calculations at all, which you will do most of the time, you need to show me that math work, okay? And no, I don't want to see a scribbled piece of paper with all your calculations on it, but I do want to see the formula that you used, and I want to see the raw data plugged into that formula, and then how you got your outcomes from there. And finally, your conclusion. There are conclusion questions that are asked within the lab itself, and that's where you're going to answer those questions in the conclusion. And make sure you make reference back to your hypothesis. Okay? So this first page talks about the hypothetical lab. The second page just asks you to develop a hypothesis and talks about objectives. Do not look at this grading rubric. It stinks. Use the one that I gave you in Google Docs, okay? Do not do the modification. That only gets done with permission from me in special circumstances. Read the directions and then click on the link here to take you to the virtual lab, which is in PhET. And it's hard for me to show this whole window. Yeah, it doesn't really allow me to zoom out here for this one, but basically what you're going to be doing is you can manipulate the variables here. You can change the height of the cannon. You're going to leave it at an angle of 0 degrees, I believe. So make sure it's at 0 degrees. And then you can actually move this cannon up and down. So you're changing the height at which the cannon is fired, because you're going to be observing the motion of that projectile. And then it gives you some data. It tells you the range, the height, the time, and over on the right-hand side, it is also showing you the angle, which we're doing no angle to start with, the initial velocity, the mass, and the diameter, possibly of the ball itself. I'm not sure that is very relevant. We are not taking air resistance into consideration here, so do not check that. You don't have to use a cannonball. You can use a golf ball if you want to. Firing a person, firing a pumpkin. They're just different projectiles, right? Different masses. Hey, they keep following the same path. What? Very weird stuff there. You got to figure out why that is. All right, so I'm not going to walk you through specifics on what to do in the lab because those directions are in the lesson planner. Gives you all the directions, how to use it, what to collect for data, and how to set up your data sheet. Okay? So it tells you how to construct your graph, what to graph, and finally, the conclusion questions. The conclusion questions. And these are what are going to go in that final section, that conclusion section of your lab report. Okay? So this one's pretty straightforward. Once you've finished it, I would prefer everything in one document. So if you're doing your graphs, let's say in Excel, if you could copy and paste them into your Word document because that makes reading way easier. Prefer everything to be done computer generated at this point as a high school student going into, for most of you, into college next year. You should know how to make graphs on your an Excel or in Word. Or I have one other option for you. And that is a super cool website called Plotty. Oh, that might be... I'll just try to get to the home page here. Okay, everybody, the website is Plotly, and for some reason they changed how it looked, so I had to do a little bit of looking into it before I continued on with the video here, but it's plot.ly, and if you click on New Chart, that's going to bring you to a page like this, which is pretty cool because all you need to do is add in your XY data, and it will create a great, cool little graph for you to use. Okay, so I like it because it's way more intuitive than using Excel or using, Microsoft Office or something like that. So we can make, you can plot your XY graph. Remember, your independent variable goes on the x-axis, so that would be maybe the height of Canon. And your dependent variable is going to go on the y-axis, and that is going to be your distance. Okay, so that's kind of what we're going to be doing here. Height versus distance is the graph that you're going to be creating. So Plotly is a great tool, and I won't really get into how to use that right now, but I'm sure there are some tools or some, web based tutorials maybe on YouTube to how to use Plotly. I'll see if I can locate one and post that up on my message boards as well. So that's it, everybody. If you have questions at all about your first physics portfolio, just go ahead and give me a call. My extension is 2204. Otherwise, you can send me a webmail message. Have a great day.